Have you ever wondered why the ice in your warm soda melts, or why water freezes in a freezer? Well, these are examples of phase change. Phase change is the change of matter from one state to another when energy is added or removed from a system. For example, phase change happens when changing phases from ice to water, or when changing phases from water to water vapor. A heating curve is a plotted diagram that shows the temperature of a substance as heat is constantly and consistently being added over time. Phase change can be seen on a heating curve. On a heating curve, the temperature of a substance rises as the substance absorbs energy. However, the temperature doesn't rise while the phase of the substance is being changed. This is shown through the pauses in the temperature on the diagram. This happens when energy is being used to change the phase of the substance rather than changing the temperature of the substance, which takes place at the melting and boiling point of a substance. For water, this occurs when water is being melted from an ice cube into water at the melting point, which is at 0 degrees Celsius. Then, from water to water vapor at the boiling point, which is at 100 degrees Celsius. During the phase change of a substance from a solid to a liquid formation, intermolecular forces that hold particles in a fixed solid formation are broken during this endothermic change, during which energy is being added to a substance, such as when going from ice to water. This can happen when an ice cube is placed into warm soda. The energy from the soda breaks the bonds holding the solid in formation, melting the ice into water. Intermolecular forces are then formed between particles during an exothermic change, as energy is being removed from the substance, changing phases from a liquid to a solid formation, such as when changing from water to ice. This can happen when ponds freeze over in the winter, due to the decrease of kinetic energy in the atmosphere, causing the water to lose energy to its surroundings. The intermolecular forces that hold water particles together in a solid formation are called hydrogen bonds. However, there are different intermolecular forces that hold different substances together. Different amounts of energy are also required to break or form these different types of intermolecular forces. There is another way to change a substance's state. Phase change can also be manipulated or controlled by the combination of temperature and pressure, which is represented by a phase diagram, in which pressure is measured in amps, better known as atmospheric pressure, and temperature is measured in degrees Celsius. As you can see on the water phase diagram, there are three curves. The blue curve represents the temperature and pressure at which water and water vapor can coexist, such as when water is heated in hot water tanks. The green curve shows the temperature and pressure at which ice and water can coexist, such as when glaciers melt due to climate change. Lastly, the red curve represents the temperature and pressure at which ice and gas can coexist, such as when dry ice is put at room temperature. It becomes a gas through the process of sublimation. Basically, these curves represent phase change during which one phase changes into another, such as when going from a solid to a liquid to a gas. There is also a point on the phase diagram that represents the pressure and temperature at which all three phases, solid, liquid, and gas, can coexist, called the triple point, where the substances all coexist in thermodynamic equilibrium. This may occur when ice water is placed into a vacuum chamber that lowers the pressure, during which the water melts, freezes, and boils all at the same time. However, solids are mostly found at lower temperatures and high pressures. Gases, on the other hand, are found at high temperatures and low pressures, which leaves liquids, which are found between the conditions of solids and gases. Overall, I hope this video helped you understand the different phases of matter, along with how and when they change phases.